Okay, so today we are going to begin our introduction to fractions. So we are going to be working this year on adding, subtracting, well, I should say adding and subtracting like and unlike fractions. But the first thing that we need to do is we need to understand what fractions are, and we need to understand what equivalent fractions are. So I need all focus up here so that y'all are ready. I'll wait. I'm greedy for your attention. No, yes, I'm hungry for your attention. I'm greedy for it. I want all of it.
Oh, you do? So if I just watch here's all my attention.
Thank you. Okay, so two or more numbers that have the same value are equivalent. So equivalent means equal. So two numbers that are equivalent are equal. Two or more fractions that have or that name the same part of a whole are equivalent fractions. So equivalent fractions are fractions that are the same size. They're equal to each other. They don't look the same, but they are the same number.
Okay, so what you're saying is like last year, but we had like this little chart to do it.
Yes.
So you're
With the hundreds chart?
So you're saying like 2 and 2 is equivalent?
Yes, they would be equivalent because they're equal, but you could also say like 2 times 2 is equivalent to 4.
Oh, okay.
Means equal. So equivalent fractions, they do not look alike, but they name the same amount. They're talking about the same amount.
So like 3 and 4? Or
So
5 and 6?
So let me show you what we're talking about here. So here's an example of 3/4. They've shaded in 3 out of 4 pieces. So 3/4 means 3 out of 4. Okay? Now, 3/4 is equivalent to 6/8. They do not look alike, but they name the same amount. 3/4 and 6/8 are equivalent.
Okay, so what you're saying is the equivalent
Let me show you, because I do not like the model that they gave you.
I know how they're equivalent.
I'm going to show y'all another model, because I don't like the one that they're using.
But that one's easy.
But it's not the same, so it's not mathematically correct.
No.
Okay, so here's 3/4. Y'all see that? 3/4. Now I'm going to draw a rectangle that is exactly the same size, but instead of 4 pieces, I have 8 pieces. Y'all see that? I have 8 pieces instead of 4 pieces. So I'm still going to shade in this exact same amount. Please stop rattling and rustling and focus on this math. This is new.
Oh, now I see. I get it more.
So, because other people need to focus and learn too.
One of them.
So do you see how it was the exact same size? And I even made the little lines in here the exact same. The only difference is instead of 4 pieces, I cut it into a total of 8 pieces. But I shaded in the exact same amount.
Oh, so what you're doing is
1, 2, 3, 4, 5, 6. So now I've shaded in 6 out of 8 pieces. So these are equivalent fractions because they're the same amount.
so both of them can be equal.
They
size,
are equal.
But
Mhm.
one of them can equal more. I know how this.
They don't equal more. They equal the exact same. They just look different.
I know how. Oh, okay. Because 3 can go into 6 and 4 can go into 8.
Yes, I love it. You just took it to the abstract mathematical. Brilliant.
I've learned this before.
I love it.
We have.
I'm so glad.
It's easy.
All right, good. I love it.
Finally, something I know.
Uh,
And I get how it's the same because yes, they're the same. They just got two little ones together equals one.
exactly. Yes.
Yeah.
All right. So that was using models to show how they were equivalent. We could also use a number line to help us. So we would come over and we would find 3/4 on the number line. And then we divide the number line into eighths. So we started off dividing it into fourths and we found 3/4. Then we go back and we divide it into eighths. And then we count over until we get to where that mark is. So we would count over 1, 2, 3, 4, 5, 6. So it would be 6/8 is equivalent. Again, you can see here how 3/4 and 6/8 are equivalent. And what Charlie was talking about, and this is really how I learned it, and this is probably how your parents also learned it, and this is what we will get to. But what Charlie said is that 3/4 equals 6/8 because we can multiply 3 times 2 to get 6 and 4 times 2 to get 8. So as long as you can multiply the numerator and the denominator by the same number, it's equivalent.
Okay.
All right, so let's use this model to find an equivalent fraction for 2/3.
I already know.
Now, what I do is a lot of times I'll just cut it in half like this. So 2/3 is equal or equivalent to 1, 2, 3, 4,
4 to 6.
6. 4 out of 6.
I'm so good at this finally. Something I know. I'm sure I might be good at it.
All right, now, we're going to use this number line to find an equivalent fraction to 1/4.
Okay, so 1/4.
Now, they've already cut it into extra little lines. Y'all see that? Y'all see how they cut it into extra little lines in between there?
Yeah, they have that.
So, how many of these little lines do we have to go over till we get to that dot? 1, 2, 3. Yep. But I'm just going to count them all. Eight.
Still out. Okay, so
So, 1/4. Let's see. Oh, I shouldn't have counted this one. Sorry. I don't know what I was thinking. I shouldn't count the 0 as 1. That's a mistake that we all make sometimes. 2, 3. There we go. That makes more sense.
I didn't even see that. I forgot that I have to do that.
Yep, you can't count the 0. My mistake. Sorry. So how many do we go over to? 2, because we can't count 0, because it means nothing. 2 out of how many?
4.
Not 4. 8. And again, if I multiply 1 times 2, I would get 2.
If you did it my way, it's just easier.
It is. 2 times 2 is 4. 3 times 2 is 6.
You're just going to get the answers.
Okay? So today we are going to practice, and I'm going to hand you your paper, and we're going to do the first one together.
I might be able to do this. I might be able to get a good grade on this one. I finally left the help this time. Miss Moore, do I ask for help? I don't. I do every Saturday if I ask for help. I'm doing Well, I ask for her. No.
Okay, let's look at number 1 together on your practice. So here, I have the fraction 2/6, and I need to find an equivalent fraction, and I need to model that equivalent fraction. So, imagine if I split each triangle into an extra triangle. So I took each triangle and drew a line down the middle of it.
So will it be 2 out of 8 or?
Well, let's now count how many are shaded. 1, 2, 3, 4. Let's count the whole thing. Let's make sure we're having our denominator correct. I literally drew a line in the middle of each dotted line, like in the middle of each triangle.
So it would be 4, 12.
So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes.
Okay. It's so easy to be. Oh yeah, because 2 times 2 is 12 and 6 times 2 is 12.
Yes. Well, 2 times 2 is 4. I know what you meant. Yes. Okay? So, there is another way that we could have done it. I'm going to start back over with this one. If this confuses you, ignore it afterwards. But listen to it now. All right, 1, 2, 3, 4. Okay. And we shaded in, how many did they start with? 2. 2 out of 6. 1, 2 shaded in, right?
Yeah.
Now, what if I took this and combine them? So instead of splitting them into smaller bits, what if I put them together into bigger bits? Like, what if I took this is 1 bit, this is a bit, wait a minute, whoop, that's a bit right there, and that.
Yeah, so the less there is like 3, number 3.
So imagine this, that's 1, okay? And that's what is shaded in. I took these 2 pieces and made them 1. Now, I'm trying to find some different highlighter colors, but I must have moved them all. All right, this will work. And then I took these 2 pieces and combined them together. And they're not shaded in. And then I took these 2 pieces and I put them together. So I had a total of 1, 2, 3. So you could have also written 1/3 is equivalent to 2/6. But if that confuses you, don't worry about it. Don't worry about it. If it confuses you, don't worry about it. We'll get there. Let's just split it. Let's just do the splitting part for now.
That was loud.
All right. On the back, you will also see some number lines. Then you will see some that are like how Charlie was talking about, how you got to figure out 3 times what is 6, and whatever you do to that, multiply the top by the same thing. Okay? Y'all looked at me like you were not sure about that, so let's look at one.
I am sure of it. I was just doing the work.
Let's do number 11. 4 times what is 12?
8. 3. No, it's not that. It's 3.
4 times 3 is 12.
Yeah.
So since I multiplied 4 times 3, I also have to multiply 2 times 3 to get an equivalent fraction. What is 2 times 3?
6. What's up? Is that easy?
So that's how we do those.
Okay.
All right, so today you're going to be creating equivalent fractions using models, number lines, and math.
Wait, did you just say, wait, to the back? So